So this is the sorry dog. Perfect. And the existing controllers right now are how many current rated? How many amps? For the oops, I'm dribbling.
Stepper drivers.
Yeah, the stepper drivers are how many amps from Gecko?
We're only using 2 amps on
2
the
amps?
big motors, but they're up to 7. So there's.
And you can.
Torch them all with those
And it's
drivers.
step control, step direction, and enable type of
the interface.
the control, the
Yeah, it's
stepper driver.
It's direction and steps. We don't even use the enable thing. It's just.
So we can replace that with any open source stepper driver.
Right.
And is there, how difficult is that? That's ready to retrofit?
To replace them, it shouldn't be that hard. We're using pins, like header pins, so the stepper drivers fit like right on there, but you can leave out those and use wires and connect them to any stepper driver you want.
It's great.
I know people who have replaced these different ones, and I definitely know there are people wanting to use open source ones.
Yeah, excellent. So this is a sample job. Wow. Here's the product. And these parts happen to be what? They're
Those are actually parts for the Lasersaur. They are the mounting board for the drive board. So we usually cut them out of acrylic.
Yep, and we've got a little smell on paper.
I'm not sure whether we adjusted the right. We were running in a little bit. Yeah, there you go.
Oh, excellent. Oh, wow. So it goes right through, even though there's 2 layers, that doesn't matter for the cardboard. When it goes, it's not solid, it's cutting through one and the other layer of cardboard.
So we use the standard lens. Has a pretty thick depth of focus, it's called. It's 75 millimeters. So one reason is you don't have to adjust it that precisely. It's very forgiving, and it works well with thick materials as well.
7.5 centimeter depth.
75 millimeters. Yeah, 75 millimeters almost is the focal length. And the more focal length you have on the lens, the more focus depth you have.
And the focus depth would be with a 75 millimeter focal length. It's going to be.
I don't know offhand, but it's more than with a 50 millimeter.
Yeah.
Lens,
Nice. Okay. Tell us about some of the structural issues, how this thing is built, just in general. A quick overview of the build process.
So it's mostly built from aluminum extrusions. These are very standard parts used all over the place in the automation industry. And
So these are the extrusions.
even the gantry is standard parts, so there are no specific rails. So we run the gantry right on the extrusions. And one reason why we do it is it scales really easily. If you want to build a bigger one, a smaller one, it's easy to do. Another thing is we have it minimally constrained, so we don't over-constrain any kind of motion, which makes it more forgiving to imprecisions in the build. For example, if those are not perfectly parallel, it won't jam or anything like that.
Yeah.
Then in the back we have the laser tube. Just it's hard to see on the camera.
Can't see that, right?
And the electronics, all the cables go back here to the electronics board.
And the build is you basically start with a frame, you assemble the frame together. What's the general process?
You assemble the outer frame, and then you do the gantry, the movable parts. Then you put the electronics in, the table, then the optics and the laser tube.
And the sheathing, the surface is at the end?
Probably at the end, yeah.
At the end?
Yeah. It's not utterly important what order you build it.
Okay. And if you were to break this down by modules, if you want to pretty much document this in modules,
we have
say
sort of subsystems, grouped parts into subsystems, wherever it makes sense. So we have actually the sort of the inner frame, which is we call it the gantry frame because the laser tube is actually mounted to one frame, and all the movable parts is one frame, and then there's the outer frame, which it looks the same on this system, but you could technically use any kind of outer frame that just carries the hull.
So inner frame, outer frame.
And it wouldn't have to be as high precision as the standard build is. So if you want to substitute it, you could. That's not what we do with the reference design. But there's a gantry frame, an outer frame. There's a table in there. There's the gantry itself, which is the x-axis and the y-axis. There's the electronics in the back. There's the laser system, which is a laser power supply and a laser tube.
And a chiller.
And then there's an external water chiller that basically cools the water that flows through the tube. And then there's the optic system, which
it's closed loop water. It's closed loop water system.
Yes.
You're not connecting this to water.
Circles it. Kind of works like a radiator.
Yep.
And then there's the optic system. And it uses flying optics, so the laser is in the back, and the beam is directed to the point where you want to have it.
That's called flying optics.
It's called flying optics.
Yep.
So it's different from actually mounting the laser tube on a robot arm directly, for example.
Yep. Is that about all the systems?
There's an air assist. So
air assist.
There's a nozzle here. So there's compressed air coming out.
That's a little pump?
There's compressed air. What is it?
A little pump, compressor?
Well, I use a little compressor. If you want, you can. So here's the exhaust fan. That sucks out the exhaust. This is the chiller. Circulates the water through the tube, and this is a little compressor.
And that's not included in our parts. These parts here.
Right. You can substitute them whatever you get locally from the hardware store.
Okay. Yeah. And do you call the skin another module or?
And the panels.
Panels,
because
yep.
we haven't mentioned those. And it mostly uses steel, 0.8mm steel panels, which are powder coated in black, and then the door is made from polycarbonate, which is see-through.
Yep.
And which blocks the laser radiation, so it's opaque at the frequency of the laser.
Yep. Okay. And the light strip is extra.
Right.
Okay.